Solve equation involving rational expressions. Here's my equation. I have two rational expressions in there. What you want to do is get rid of the denominators by multiplying both sides by the common denominator of x and x squared, which is going to be x squared. So we're going to multiply both sides by x squared. On the left, the x squared needs to distribute to all three terms. X squared times 1, that's x squared. X squared times 15 over x, that'll give you 15x squared over x. And x squared times 56 over x squared will give you 56x squared over x squared. On the right hand side, 0 times anything is 0, so we just end up with 0 on the right hand side. Now let's simplify this down. There's an x top and bottom here that'll divide out, and the x squared here also divide out. So we end up with x squared plus 15x plus 56. Now to be able to solve this, realize that it's quadratic, and we can actually solve this one by factoring it, because this is going to factor into two binomials. You need to think of two numbers that multiply to 56 but add to 15. That's 8 and 7. So this is going to be x plus 8, x plus 7. Now we use the zero factor property that states that when you have factors multiplying to be 0, at least one of them's got to be 0. So either the x plus 8 needs to be 0, or the x plus 7 can be 0. And these can be solved by subtracting 8 on both sides here. You get x equals -8. And subtracting 7 on both sides here, we get -7. Now, one important thing with solving equations like this, whenever you start with a variable in the denominator position, you need to make sure the answers you get do not make any of these original denominators 0, because then we'd have to kick them out of the solution. But neither -8 nor -7 make any of these denominators 0, so I'm good to go. So your answer to this equation, there's two values, -8 and -7.